Example 11, we've got n to the fourth plus 3n under the radical and n squared minus n on the bottom. So let's see, up top, this is going to act like n squared. And this down here is going to essentially be n cubed. This is going to diverge because it's going to wind up being like n squared over n cubed, which is 1 over n. It's going to be like the harmonic series. So it's going to diverge. But let's actually work that out. All right, so up top, let's see. Actually, let me use a little more space. We want to compare 2. On top, we've got square root of n to the fourth, and on the bottom, we've got n cubed, because those are our two dominant terms. So you can rewrite this as n squared over n cubed, which is 1 over n, which diverges. All right, so now we just need to see, can we use the comparison test or the limit comparison test? Honestly, we know it's going to diverge because we got this by pulling out exactly the dominant terms on top and bottom. But let's still work it out. Let's see, if I compare n to the fourth plus 3n, if I compare that with n squared, or if I want to, I could write it like this. This over here is going to be bigger than that, so that's going to make this bigger. And then downstairs, n cubed minus n, and compare that with n cubed. This is a smaller value than that, which makes this number over here bigger. So we get this, and so this series over here we know diverges. This series is bigger, so this is also going to diverge by the comparison. Now, I just noticed there's one problem with this example. I was a little sloppy when I wrote it. On this one, technically, if n equals 1, I shouldn't say technically, this is true. If n equals 1, the denominator is 0. I probably should have written this problem starting at 2, just to avoid that. All right, problem 12. Let's see, problem 12, if you look at that one, it's an alternating series, but more importantly than that, it's a geometric series. We can tell that because the top and bottom are both a number raised to n plus or minus some constant. It's geometric. The ratio is going to be 3. Well, the ratio is negative 3 halves, 3 over negative 2. Therefore, it's going to diverge. All right, what about 13? 13, we've got 3 minus n squared over n plus 2n squared. So on both of these, we've got my dominant term up here is this, and my dominant term here is this. Notice those are the same degree. So if you take the limit as n goes to infinity of our terms, notice what you're going to get. You're going to get negative 1 over 2. That's not 0, so that's going to diverge by the test for divergence. All right, and finally, our last problem, we've got n factorial over 1,000 to the n. Now, interesting thing here, if you tried to calculate this, or if you tried graphing it and looking at it, it would probably look like it's going to converge, but this thing actually diverges. The reason is these numbers are going to get huge. So let's okay. All that aside, how do I know which test to use? There's a factorial, so definitely use the ratio test. the n plus first term is going to be n plus 1 factorial over 1,000 to the n plus 1. So I'm going to take my limit as n goes to infinity. And let's see, the n plus first term is going to be n plus 1 factorial over 1,000 to the n plus 1 times the reciprocal of the original thing. So it's going to be 1,000 to the n over n factorial. All right. So I'm going to rearrange this. N plus 1 factorial, I'm going to put that over n factorial. And I'm going to go ahead and rewrite it though. Instead of calling it n plus 1 factorial, I'm going to unroll that n plus 1 out of there. So it's n plus 1 times n factorial. Now the 1,000, I've got 1,000 to the n. Down here I've got 1,000 to the n plus 1. And I'm going to do the same thing there. I'm going to take that plus 1 off and just multiply by 1,000. That way we've still got our n plus 1 factors of 1,000. Okay, now we can cancel these guys. We can cancel these guys. And when n goes to infinity, the top's going to go to infinity and the bottom's going to be 1,000. So infinity over 1,000 is still infinity, which is bigger than 1. So therefore this is going to diverge by the ratio test. And that's it.